So in this session, we're going to learn how to count by two, how the binary number system works. And this is a funny joke t-shirt kind of comment that you'll see amongst computer scientists, and hopefully by the end of this session, you'll think it's funny too. Counting by something other than 10 is not actually new. You probably are quite adept at counting by 12 and also by 60. If you bake in the imperial system, you have the strange capacity to count by 2s and 4s and 8s and use all different kinds of words for numbers. If I ask you how many seconds are in 1 minute and 23 seconds, can you do it? How many quarts are in 1 gallon and 1 quart? Okay, so stop and think. What's the method that you use for figuring out how many seconds are in 2 hours, 7 minutes, and 5 seconds? Take a moment to think about that and write down what method you would use. We call the number system that we're used to a positional number system because the actual value, or what a digit stands for, depends on what place or what position it's in. So we know that the rightmost digit here, 2, that stands for 2 times 1. We know that the next one, 7, it's just the digit 7, but we know to interpret that as 70, 7 times 10. And likewise, the 3 is actually 300, and the 4 is actually 4,000. And we're going to do the same thing in binary. The first digit, the one to the right, is going to stand for 1 times 1. The next one is going to stand for 1 times 2, and then 1 times 4, and then 1 times 8. So the same way that we did with decimals, it was 10 to the 0, which is 1, 10 to the 1, which is 10, 10 to the 2, which is 100, 10 to the 3, which is 1,000. We're using the same principle here, that we've got the units place, the 2's place, and then the 4's place, which is 2 to the second power, and the 8's place, which is 2 to the third power. Here's those same calculations written out as an equation. So 4372, for another value, we say 4 times 10 to the third, plus 3 times 10 to the second, plus 7 times 10 to the first, plus 2 times 10 to the 0. And similarly for 1011 in base 2, it's going to be 1 times 2 to the third, 0 times 2 to the second, 1 times 2 to the first, 1 times 2 to the 0, which is 8 plus 2 plus 1, or 11 in our base 10 system. So these are the numbers written in base 2 from 0 to 7. How do we read them? You can read them as 0, 1, 2, 3, 4, 5, 6, 7. But you'd also read them as 0, 0, 1, 0, 1, 0, 0, 1, 1, or just 1, 1, 0, and then 0, 1, 0, 0, or just 1, 0, 0. Some people will say 10 base 2 when they mean 0, 0, 1, 0. You could say 101 or 100 base 2 to convey 1, 0, 0. But the simplest one is just read the digits. So just 0, 1, 1, 1. Now, it turns out that one of the beauties of the binary number system is there are lots of ways to represent those numbers or to symbolize the numbers, since all we have to do is symbolize a 0 and a 1. So here's your stop and think problem for the day. Read each of these 5 pictures as a binary number. So some Timbits, some signs, some switches, some bowling pins, and an apartment house with some windows lit up at night and some not. So give that a try, and then as you get started, the first slide will give a quick explanation of those.